Morning all of you. Welcome back to course database management system. So our today's topic of video is testing for serializability. So in today's video we are going to discuss the numerical based on serializability. So in the last video we have seen the concept of conflict serializability and view serializability. So there we understand what are the conditions for conflict serializability and what are the conditions for view serializability, and when particular schedule is called as a conflict serializable and view serializable. So in this video I will tell you how to solve a numerical based on conflict serializability. Okay, so let's discuss the numerical based on conflict serializability. So before discussing this numerical based on conflict serializability, first of all we'll discuss the algorithm, how to generate a precedence graph, because in case of conflict serializability numerical you need to generate a precedence graph. So in that case you should know how to generate a precedence graph, what rules you need to satisfy, so which algorithm you need to follow. So you have to follow this algorithm in order to generate a precedence graph for given schedule. So what is step 1? You have to create a node labeled with TI in a precedence graph for each transaction. Whatever may be the number of transaction is present in a particular schedule, that many node you have to create. Then you have to create the edge between the node Ti and Tj only if one of the calling condition is true. What is the condition? That Ti execute write queue before Tj execute read queue. So in short I will tell you what are these conditions. The condition is very simple. Between read there is no conflict, but between read write read and write there is a conflict. Suppose you find read write, then you can draw the edge. Suppose you find write then you can draw the edge. Suppose you find write read, then also you can draw the edge. But suppose you find read then there is no edge. And the condition is in that they are accessing the same data item. Suppose one read is performed on data item A and another operation is suppose read operation is performed on data item A and write operation is performed on data item B, then there is no problem. But the condition is that both should access same data item, then there is a conflict. So in this way you can draw the edge. And in the step 3 you need to check whether cycle is formed in the precedence graph or not. Suppose the cycle is formed, then schedule is not conflict serializable. And suppose the schedule is not conflict serializable, so in that then schedule is not conflict serializable. And suppose there is no loop or no cycle, then schedule is conflict serializable. So this algorithm is important in order to generate a precedence graph for given schedule. Now let's discuss the numerical. So this is a numerical given to you. For each serializable schedule, determine the equivalent serial schedule. So these 4 schedules are given to you and you have been asked to generate serial schedule. So let's see how to solve this kind of numerical. And in this case we should know whether we can able to generate serial schedule for each and every schedule or not. So whenever you will get such kind of numerical, very first step is that what you need to do, you need to have a representation like this. First of all you need to have representation like this. So here what I have done, I have written transaction T1, T2, T3. So how I have written T1, T2, T3, why not T4, T5? So how do I come to know that only 3 transactions are there? So I read this thing. So here you find R1, R2 and R3 or W3. That means from this I come to know that there are 3 transactions are there. That's why I have drawn this T1, T2, T3. Suppose I found W4 also, then I can have T4 transaction. So very first step is what? You need to identify how many transactions are present in a given schedule. So in this schedule there are 3 transactions are there. So I just written T1, T2, T3. Then you need to arrange all these operations in this transaction. Very first R1 of X. So I just written R1 of X and it is performed by T1. Then R3 means what? It is being executed by T3. But after this means you don't have to draw in the same, but after means first of all this operation is performed, then this one R3, then W1, that means it is performed by T1. then R2, and then W3. So in this way you need to have representation of a given schedule, okay, so that you will not get confused and you will get the sequence, in which particular sequence that set of operation is being performed. Okay, now the next step. In the next step, what we need to do, we need to draw the precedence graph for this particular given representation. Now how to draw a graph, how to draw a precedence graph for it. So here first of all I just created this node T1, T2, T3. Why? Because there are 3 transactions. Now how I had drawn this edge? So I will tell you. First of all, you need to compare. You need to start from very first operation. Then you have to compare between this read and read whether conflict will occur. No. Between read there is no conflict. Between this read and write conflict will occur. No. Why? Because they belongs to same transaction. If though the operation is read and write, but they are belongs to same operation, that's why there is no conflict. Then between this read and read, no, between two read no conflict will be there, but between this read and this write there is a conflict. So what you will do, you need to draw this edge. What is the data item? X. So what I have done, I have just drawn the edge from T1 to T2, sorry, T1 to T3. I have drawn a edge between T1 and T3 for data item X. Okay, for data item X I have drawn a edge between T1 and T3. Then T3, then next is R3. Now just forget about this R1. Now you just consider R3. Now this R3 is compared with next, whether conflict will occur between these two. Yes, here is read and here is write, and transactions are also different, so conflict will occur between T3 and T1. So I will draw the edge between T3 and T1 for data item X. Then between this two, no, there is no conflict, and between these two also there is no conflict because they belongs to same transaction. Now next you have to consider this operation. Now this operation is compared with this, whether conflict will occur between these two. Yes, there is a conflict because one is a write and second one is a read. So you need to draw the edge between 1 and 2 for data item X. Then between this write and this write, yes, there is a conflict because two transactions are different, and we know that between two write there is a conflict. So I will draw the edge between 1 and 3. Already I have drawn this. Now I need to consider this R2 and W3, whether conflict will occur. Yes, between 2 to 3 there is a conflict occur for data item X. So we have drawn this edge for data item X. So in this way I have drawn this particular precedence graph. Once you reach up to this, you need to stop. You need to start from first operation and you have to end with a last operation. So in this way we have developed this precedence graph for this particular schedule. Now we have to check whether cycle exists in this particular graph or not. Suppose there exists a cycle in this graph, that means this schedule is not conflict serializable. So do you find any graph, do you find any cycle? Yes, there is a cycle between T1, T3 and again between T3 to T1. That means there is a cycle. So you need to write explanation like this. It is not conflict serializable. Why? Because it contains a cycle. So here you can see between T1, T3 and T3 to T1. So this is one cycle. Again between T1, T2, T2, T3 and T3 to T1. So as this graph consists of a cycle, that's why this graph is not conflict serializable. As this graph is not conflict serializable, you cannot generate serial schedule for this. Okay, so in this way we have solved this first bit. Okay, now we have to solve this next bit. Okay, this is the next bit that you need to consider. So again the step is common. First of all, you need to have representation like this based on number of transaction. Again we come to know that there are 3 transactions are there, so we have just arranged all these operations in this particular transaction. So we have written like this. Then what we need to do, we need to generate a graph for this. Again I will tell you the procedure, carefully observe this. I need to start from very first operation and then I need to compare with all the rest of the operation. Okay, So this R3 is compared with this, whether conflict will occur between these two, no. Then this compared with this, whether conflict will occur between these two, no. Why not? Because they belongs to, though the operation is read and write, but they belongs to same transaction. That's why there is no conflict between this R3 and W3. But between R3 and R1 there is a conflict, no. Between R3 and W1 there is a conflict, yes. Between 3 to 1, so you will draw the edge 3 to 1 for data item X. Then this R2 compare with W3, whether conflict will occur between 2 and 3, yes. Between 2 and 3 conflict will occur for data item X. Then between W3 and R1 there is a conflict, yes. Between 3 to 1 there is a conflict for data item X. Between this 3 1, yes. Between 3 and 1 already I have drawn the edge. Then this R1 compared with this W1, there is no conflict. So in this way we have drawn a graph. So we come to know that there is no cycle form in this particular precedence graph. Hence we can say that this is a conflict serializable graph. So as this graph is conflict serializable, we can able to generate serial schedule. Now how to generate serial schedule? Just look at this particular graph and tell me what will be the starting point. So here you will say that what is the starting point, whether I should start from T1 or I should start from T2 or I should start from T3. So you need to check for that from where you need to start. Suppose I start from T1, can I able to visit T2 or T3? No, so I cannot start from T1. Next possibility is T2, can I start from T2? So from T2 there is a T3 and from T3 there is a T1, yes. So I should start from T2, so T2, then T3 and T1. So this is what a serial schedule for this particular schedule. In this way I got the serial schedule for this given schedule, because in the numerical it is being asked to determine the serial schedule. When you can able to determine serial schedule, suppose it is conflict serializable, and when this graph is a conflict serializable, when this schedule is conflict serializable, when precedence graph does not consist of cycle, then we can say that schedule is conflict serializable. Suppose it is conflict serializable, then you can generate the serial schedule. So in this way we have generated a serial schedule for this given schedule. So in the previous bit we have seen that there is no serial schedule because it is not conflict serializable, but in this bit we have seen that we can able to generate serial schedule because it is a conflict serializable. And how it come to know that this is a conflict serializable? Because there is no cycle form in the precedence graph. So in this way you need to solve a numerical based on conflict serializability. You can able to check between given schedule is conflict serializable or not. So in this way you have to solve. So you need to remember the condition. First of all you need to have representation like this. You need to arrange, first of all you need to identify how many transactions are there, then you need to arrange all these operations as per the sequence. Then you need to generate the precedence graph by following the algorithm, where you need to draw number of nodes equals to number of transactions. Then you need to draw the edge when there is a possibility that there is a conflict between the two operations, then you need to draw the edge. Once you draw all the edges, you need to check whether it consists of cycle or not. Suppose that graph contains cycle, then it is not conflict serializable. Suppose there is no cycle, then it is a conflict serializable. So in this way you can able to solve a numerical based on conflict serializability. Thank you.